Hello everyone, my name is Ha Hong Sun, and today I'm gonna introduce you an email to readable Vietnamese text conversion algorithm for use in text-to-speech application. We're now going into the six main part: introduction, methodology, result analysis, conclusion, acknowledgement, and finally, reference. Last few years, the development of chatbot and voicebot are replacing humans in performing daily tasks such as registration, gathering information, surveying customer feedback, and more. Therefore, string manipulation and text analysis are becoming more and more important, especially in natural language processing application, part of which is text-to-speech. For example, due to huge amount of users, the telecommunication corporation should be replace operator with Autobot to perform simple tasks such as giving user a simple information, phone number, name, or email. However, the processing time must be as short as possible, since it's one of the most important factors in the customer interaction rate, which results in the profit of the whole corporation. Some authors have worked on email researching, such as email spam detection, content classification, email validation, and more. Use machine learning-based naive-based algorithm and computational intelligence-based particle swarm optimization for learning and classification of email content as spam and non-spam. A. Buckley, T. D'Asaso, M. D. Ambrose, and M. Lanza has approached to classify email content at the line level. On the other hand, some other authors propose a novelty, which were the use of clustering by compression in order to find a similarity in the content of the email. V. R. Savilla and C. G. Philippe has gave the solution of recognition of the sender of an email, and moreover, the improvement structure used the text mining algorithm to hint at change yield. Their framework utilized the Enron email dataset as a contribution for distinguishing and finding the genuine sender of an email. The framework utilized this Enron email dataset, which contained 500,000 emails of 150 users, and as per folder like sending mail, receiving item, and so on. Realize that in order to read an email which is unstructured in nature, it requires to first split the email into distinct readable words. Therefore, the task may be complete in the least time possible. With this approach, this paper proposed an algorithm to split the email into readable words. Nevertheless, a TTS API is used to return the output in the audio form and can be played immediately. Here, the algorithm is simple and efficient for splitting an email into readable words. This is evident through the achievable average processing time of 1.7 milliseconds with accuracy up to 86.67% on a test of 60 random email. And now we'll move on the next part: methodology. In this work, several essential Python libraries are used to improve the user's experience when using the developed algorithm and to save development time. They are presented as follows. The first one is Pandas. This is a famous Python library written specifically for data manipulation and analysis. Pandas provides data operation for alternating numerical time series and table. In this algorithm, it is used to read and edit transcript file and can be used to read email list as input. The second one is Pronouncings. Pronouncings is a useful library which can be used to get the form of English word so that it can be transformed into any language pronouncings. The third one is PyTTS X3. PyTTS X3 is a library which provides a TTS conversion which can be used offline. However, it has limitation of using only for English. The last one is the play sound. In order to enable sound playing for users to get the results in an audio file, this library is used. With the help of the play sound library, the output audio file can be played right away. The next one is the proposed algorithm. This is the algorithm flowchart. First, when the program starts, it will import essential library. Next, it will assign the input, in this case is email, in the variable name word. Next, the program checks the word. If it is empty, it will return an empty string and end the program. If the variable word isn't empty, it will concat each letter from variable word to a variable name temp. Next is check if the variable temp is still readable. If it is true, it will check if it is the end of the variable name word. If it is not, it will continue to concat letter from word to temp. If it is the end of the word or the variable temp is no longer readable, it will get the last readable word and get the rest of the word as a new input. It is very important to understand the vowel and consonant in Vietnamese language, since it is the parameter to build a perfect word in Vietnamese, and developer can be able to generate Vietnamese words based on only vowel and consonants. This is a vowel and consonant in Vietnamese. And this is a function to split the word into readable Vietnamese word. And this is the function to get an email into the readable Vietnamese text. And this function take input is as an email array and return the array of results. The next one is the algorithm to get the output as an audio file. I send the request to an fpt.ai server and it will return me a URL with the audio file in it. We can get the URL or we can play the audio file immediately thanks to Play Sound Python library. After testing 60 different emails, the program returned the correctly 52 email case. So the accuracy of the algorithm is 86.67%. It is designed to return only the longest readable words, so sometimes it causes unexpected results in the testing emails. Below is an example of the error that the algorithm causes unexpected. As you can see, the results of the algorithm is vun h arc fpt.edu.vn. It is readable, but it's not correct as we want. We expected it would be vu n h arc fpt.edu.vn. So it is well, each of us can understand a string in many ways. So on the algorithm. In conclusion, this work has presented an algorithm to split the email into readable words. It is applicable to Vietnamese language and can be further expanded to support the other language. This will improve the algorithm accuracy, processing time, and update new words in the dictionary in the future. Acknowledgement. We would like to thank the FPT University to support us to complete this work. The final part is the reference. And that's we cover it. Thank you for listening to me, and I wish you a good day.